So number one is going to be learning target number 10. Okay. So what's the first thing you have to do here? Who wants to answer that? Ella. We got to find the GCF. So I will do this really, really quickly here. We know it'd be 4 and 4, 2 and 2, 2 and 2. Okay, and then 24 I'll do over here. So 3 and 8, 2 and 4, 2 and 2. Now what do I do next? What's the next step of this? Yep. Stack them up. So we know it's 2 times 2 times 2 times 2. And then and then the other one is 2 times 2 times 2 times 3. And then what do I look for here? Yep. Bell. We look for the CFs. We've got to look for all the CFs. And if you have multiple CFs, what do you do with them? What do you do? Yep. You multiply them. So 2 times 2 times 2 times 2 is 8. And then remember, it's like this. We have to think distributing. What would I multiply 8 by that would get me back to 16? Yep.
2.
By 2, and then 8 times what would get me back to that? 3. Good job, and that's your answer. Okay. The one group that did this one, that is equal to that right there, but you did not use the greatest common factor. You used just a common factor of 2. Okay? So just make sure you're using that GCF. So these numbers right here, they are already decimals. So we know that we should always stack up our decimals when we're comparing decimals, right, everybody? And I can add a 0 here, then we always work our way left to right. So in the ones place value, we didn't learn anything. What about the tenths? Yes, since that 5 is bigger than the 4, none of this other stuff matters. So then we know it's got to be a greater than symbol. It's trying to eat the one with the 5 and the tenths place value. Okay, you're going to have to determine what is a composite and what's a prime number. Now, here, I'll write this. A prime number is what? What does a prime number have? Malou?
Only one factor or
2
2?
factors only. That's it. It has factors of 1 in itself. Whereas composite numbers have 3 or more factors. So when we look at the number 11, that is prime because it can only be divided by 11 or by 1. 23 is the same way. It's prime. Okay, 13 is prime. The only one that's composite up there is 21 because it can be divided by 1 and 21, but what else can it be divided by? Yep. Gibbs?
3 and 7.
3 and 7, right? So that's why it's composite. It has more than 2 factors. All right. Okay, so this one, same type of question here. It's want to know which one is a composite number. Why is that one composite right away? Why did you know that? What jumped out at you, Grace?
The others are all prime.
Yep, that's one way to think about it. She knew that the others were prime, but what's another way that you knew it's composite, Rosie? It ends in a 5. If you have a number other than 5 and 0 that ends in 5 or 0, will it always be composite?
Yes.
Yes, it will. Yes, it will. Good job. Okay, so we have to find the GCF of 27 and 36. So right now we would do our trees and everything. I'm just going to skip it. Not that you're allowed to, but just to save a little time. It would be 3 times 3 times 3, and it would be 2 times 2 times 3 times 3. What do they have in common? They have one set of 3s, but do they have another set of 3s, guys? Yes, they do. So that means the GCF is 9, and then you have to say, okay, if I were distributing this 9 through there, then 9 times what would give me back to 27? Everybody? 3. 9 times what would give me to 36?
4.
Good job. Now, if you're one of the 2 people that, or one of the 2 groups that got that, that is an equivalent expression, but the problem is, what didn't they get? What didn't they use? Ella? Yeah, they didn't use the GCF, right? 3 is a CF. Do we all agree 3 is a CF?
Yeah.
Obviously it is. See, they're circled. But we have to use the GCF in these to get it right. Okay, so they're doing the distributive property correct. Miss Click? Okay. Yep, that's fine. Yep, that's fine. All right. Good job getting this one right for the most part, except for one group. An interval, remember, is how much the number line itself is going up by. So if I had a number line that was doing this, 10, 20, 30, what would the interval be, everybody?
10.
Tens. It's what it goes up by from one little spot to the next. So here, it went from 2 1/5 to 2 2/5. So if you're thinking about addition, you would be adding 1/5, right? And you can see you did that for all of them. So that, and then this would be 2 5/5, which we know equals what?
3.
Equals 3. So here we have an LCM question. Now, I think you guys all figured out that it was LCM. How do we know it's an LCM question, guys? How do we know that? Because that's really what we got to do. Yeah? Yeah, we're talking about next time, right? We're talking about same time. So what does that mean we're really talking about? What word did I really want you to remember? Yep. Future. Anytime we're trying to figure out when two events are going to happen again in the future, we are always talking about LCM. Now, I see that we all know how to find it. We find the GCF first here, so 5 and 12, and then 2 and 6, 2 and 3. What do we find the GCF to be? Huh? It is 1. The GCF is 1. So that means to find the LCM, we're going to take that GCF of 1, and we're going to multiply it by everything else, right? Which we get 60. So do you guys all agree that the LCM is 60? Yes, absolutely. That's what the LCM is. It is definitely 60. I see people writing. I see people doing other things. I need you with me, please. Thank you. Okay. That means every 60 minutes. Are they going to finish a chapter at the same time? Yes, they are. That's exactly what it means. So for those of you that put 60 as your answer, and there were 3 of you that put 60, why is that not right? Why is that not right, Bella?
Because it says the next time, so it has to be a time.
Right there's your key. It says, when is the next time? When is the next time? So if it's 60 minutes, sure, that is the LCM, but you've actually got to say, okay, well, that's 1 hour, so what's 1 hour after 4:15? 5:15. You will have one just like this on the test tomorrow. Identical to it, except for the numbers are different. But the actual understanding of it is the exact same. Did everybody hear it? It's going to throw people because a lot of people are going to want to give me 60, but that's not the answer. Okay? So which one of these is a prime number? So when I looked here, what is the first thing you saw when you saw 33? Shouldn't you have said, well, is it even or odd? Do you guys remember this?
Yeah.
And it's odd, so we've got to check what?
3,
3, 5, and 7. So we check 3 by adding the digits. 3 plus 3 is 6, correct? Is 6 divisible by 3? Since it is, we know that this is a composite number, so that's why it's not going to work for this. 29. Let's go to 45. It's even or odd. We're going to check 3, 5, 7. 3, 4 plus 5 is 9. It does have 3. It also ends in a 5, right? So yes, that is also composite. So it comes down between these two. Even or odd, we're going to do 3, 5, or 7, right, everybody? So 2 plus 9 is 11. Is 11 divisible by 3?
No.
Nope. Does 29 end in a 5 or a 0? And is 29 a multiple of 7? No, it's not. Because if you did 7, 14, 28, 35, there's no 29 in there, so that's out. Because none of those are factors, we know this is a prime number. Why is 1 not a prime number? Yeah, go ahead.
Because it's neither.
It is neither, but what makes it neither? Why is it not prime, Katie?
It only has 1.
It only has 1 factor. How many does it have to be a prime number? 2. Composites are 3 or more. Yes, like this. So, we know that whenever it asks for the prime factorization, we should all know that means the tree, right, guys? So yes, and that's really not the hard part. You guys are good at that. You've done it so much. Remember, prime factorizations cannot just be a list of numbers. You've never once just seen me do this, right? When I'm listing them out, what do I always put between them? Malou?
Multiplication.
Yeah, multiplication signs. Now, what I want you guys to really focus on is it might ask you for the prime factorization. If it does, then this is what you do, the tree. Right, everybody?
Yes.
What you guys will be confused on tomorrow, and I would really appreciate if you listen because I'm trying to help you, is it might ask for this. What is how do I say it? What is the product, sorry, I'm just trying to think how I have to word it on the test. Product of its prime, prime factors. So if you ever hear the phrase, product of its prime factors, right there. So it's that. And I think it says, what is the product of its prime factors for 36 or something like that. But if you hear that statement, product of its prime factors, that means the exact same thing as that. Does everybody understand me on that? It's the same thing because look, isn't this showing a product of 36 as prime factors? That's what it's showing. Product means multiply, and then prime factors, there's your prime being multiplied. That's what it is. So it might not always ask for this. It might ask for this. It's the same thing. Do we all got that? Okay, so now, I knew this was, you guys did better in second period. Sorry if second period's listed on the video. But anyway, they were about split half and half, right? So, yeah, these are definitely going to be multiples because we're talking about the product of two numbers. So 3 and 2, or 2 and 3 are being multiplied. The actual multiple itself is the sixes, and then 6, 12. I really don't necessarily love that definition, but those are multiples. 5, 10, 15, 20, 6, 12, 18. Factors are the numbers that divide the number evenly. So 2 and 3 are factors of 6. Do we all understand that? Factors are always smaller. Multiples are bigger, or as big as your number, identical to your number. Okay. So this one here, we had to find the LCM. We had a couple of you select 2. Now my question to the people that selected 2 would be, okay, if we're talking about least common multiple, if I were thinking about the multiples of 8, that would be 8, 16, 24, 32. The multiples of 12 would be 12, 24, 36, so on, right? So how could you get, not like 2 is not a multiple of either of those numbers. It's a factor, but it's not a multiple. And then we did have one person put 96, so they just went a little bit too far. So what's the first step to finding LCM? What's the first step to find LCM? AT. You got to find the GCF. So you should, again, do your trees. I'm going to skip it just for time's sake. It would be 2 times 2 times 2, and 2 times 2 times 3, right? Everybody got that? We know that we have common 2s, common 2s. What's the GCF, first of all?
4.
It is 4. Good job. Okay, now, who wants to tell me step 2 then? What do I do on step 2, Grace?
You would multiply the GCF by the common factors.
So I take the 4 by the non-common factors, right? So the 4 times anything that's not common, so 2 and 3. So we multiply it, and that's where we get 24. If you got 96, unless it was a misclick, of course, but if you got 96, I think you had an extra 3 in here. Well, actually, an extra 4. I see, I'm not sure. Maybe you added in the 4 from your tree or something. I'm not sure. But regardless, that's how you find LCM, okay? On the video. So LCM again here. You got to do your trees, find the GCF first. The trees would end up giving you 2 times, oops, it'd be 2 times 3 times 3 would be 18. 12 would be 2 times 2 times 3. You can see there's a common 2 and there's a common 3. Therefore, my GCF would be 6, right? And then 6 times everything not circled would be times 2 times 3, which does give you 36. And then you should always just make sure, ask yourself, is 36 a multiple of 18? Yes, it is. Is it a multiple of 12? Yes, it is. All right, listen. So here we have Mr. Garrison changing his wiper blades every 15 minutes and rotating his tires, or every 15 weeks, sorry, and rotating his tires every 6 weeks. If Mr. Garrison did both of these tasks this week, in how many weeks will he have to do both of these tasks again at the same time? Keywords, real quick. Hurry. What keywords do we see? Raise your hand. Bella.
Well, it's not immediate, but it's future.
Future, absolutely. That's the one we only care about. Give me the other one there, you.
Again.
Again is there, same time, any of those. So we know it's going to be an LCM. So finding the LCM, we've done it many times. I don't think we need to do it again. The GCF would be 3, and then it would be 3 times 5 times 2, right, is what it would end up being. So that would be your LCM of 30. So good job. You will have one just like that on the summative, or on the formative, by the way. Guys, real quick. So there's 2 ways you can go about doing this, guys. 2 ways. Here's the first way. If you wanted, you could convert this into a fraction. So we know that's 618,000, so you write it exactly the way it sounds as a fraction, right? Then we have 5/8. Now we've got to find a common denominator. What would be a good common denominator to use here, Ella? 8,000 would be perfect. Times 1,000 there, so we're going to have to times 1,000 there. We have to times by 8 here, so we got to do the same thing to 618. I think it's 4,900 and, anybody do it? No. I don't remember what it was. It doesn't matter. Okay, it's something like this, 4,900 and something or other. Regardless, we can tell that that one's larger, right? It's less than. It's less than. But I have a feeling the majority of you left this as a decimal and converted this to a decimal. And you would do that by doing 5 divided by 8, which you cannot do, so you've got to add a decimal, and then the decimal goes straight up, and then we add a 0. 8 goes into 56 times. Now, is that enough information right there to be able to compare them? No, we've got to keep going because it's got a 6 and the tenths in both of them. So we got to keep going. So we got to add another 0 on there. 8 goes into 22 times. Now, do we have enough information now? So we have 0.618, and we have I don't know why I put 2 ones, sorry. And then we have 62 hundredths, and you can put it there. Draw your line, nothing there, but the 2's larger, therefore this one's larger, and we know it's got to be a less than somewhere. Everybody got that? You've got to show one or the other, common denominators or the decimals. Okay? So these are going to be the factors. So good job. We still had a couple of you say multiples, but factors are the numbers that multiply to get a product. So for instance, 5 times 6, that's 2 numbers being multiplied to get a product of 30, right? So 5 and 6 aren't the multiples of 30, though, are they? They're the factors, right? So another LCM question there. If you did it, if you worked it out, you would have this right here, 2 times 3, and 2 times 2 times 2. The GCF is 2, and then you would have to do 2 times everything that's not common. So that's where you would get 24 there, okay? This. So right here, you had, whoops, I didn't want that. You would have found that once you did your trees, you would have 2 times 2 times 2 times 2 times 2, I think, and then you'd have 3 times 5. They don't have any prime numbers in common, but what they do have is 1, because all numbers share a 1. So that would be your only common factor and your greatest common factor. Okay, so factors, good job. What people did in my second period, they were saying, they were like doing the trees and everything, and then they got, okay, 2 times 2 times 5. And then they said, oh, then it's 2, 2, and 5. Now, that's not an option. Now, that's the prime factorization, but that's not what it's asking for, is it? It's asking for all the factors. So we know we must start with 1. So red would be out. And obviously green, if you put green, if you're the group that chose green, you were giving me, again, multiples. We're not understanding the difference, but that was a misclick, as I was told. So those are the multiples, factors. The first one will be 1, and then this is where you did your factor rainbows, right? 1 and 20, 2 and 10, 4 and 5, and that was your factor rainbows, right? Okay. So, I will tell you right now, my friends, this is definitely on the test tomorrow. Wink, wink, hint, hint. This question is on the test. Can't make it any more clear. Okay, so Marissa's organizing her DVDs into gift boxes to give her favorite friends. Aw. She wants each box to be identical to the others. Okay, what are some key words that you already see in there? Grace? Identical. I see the word identical. What's an even better one than what she just said, which was great, but what's a better one? Yeah? Belle?
Great.
Yeah, that's down here. That's fine, but there's an even better one. AT?
Boxes.
Boxes, guys. Whenever you see boxes, isn't that a type of groups? And anytime we see that, what are we talking about? Ella? GCF. Good job. Definitely a GCF question. Now, what this question does is it actually gives you the GCF, doesn't it, guys? Doesn't it?
Yeah.
So I gave you that answer. I didn't make you find it because we found GCF all day. What I asked you to do was apply the GCF. So if I have 7 boxes, which I'll draw right here. 1, 2, 3, 4, 5, 6, 7. My boxes got worse as I went. Okay. That's 7 boxes. If I want to know how many mystery DVDs are going to go into each box, how am I going to figure that out? How am I going to figure out how many mystery DVDs are going to go into each box? Yep, Dominic.
14.
Yep, you're going to take the total amount you have, 14, and you're going to divide it by the amount of groups that you have, and that's where we get 2. Does everybody got that? So if you're one of the ones that missed it, which we had only 2, we had everybody missed it. Okay, I'm sorry. Everybody missed it. So you guys all did the GCF, so you didn't read very carefully.
No, one person got it right.
I know that. I meant 1 is what I meant. I don't know why I said that. But, yeah, you guys all did this, but that was actually asking you to apply the GCF. And then the one person that put 14, maybe you were just, I'm not sure. We just got to read it a little more carefully, that's all. Okay. So another question, we have to determine whether it's prime or composite, right? That's what we're doing, or neither. But when I go through here, I see this one is even or odd, guys. Odd, so I've got to check 3, 5, and 7, okay? So 3 plus 9 is 12. So yes, that's divisible by 3. So that's a composite number. 3,428. How do I know that's composite right away? How do you know that right away, Braden? It ends in an even number. We know that all even numbers are divisible by 2. Therefore, they cannot be prime unless it's 2 or 0, of course. Good. Okay. 51, we say, is it even or odd? It's odd. So we're going to check 3, 5, and 7. What's 5 plus 1? Everyone? 6. Is 6 divisible by 3? So yes, that has a factor of 3. So that's composite. The only one that wouldn't have 3, 5, or 7 would be this one. You can't really see it when we're writing in blue, but you get the picture. All right. So multiples, remember, are always getting bigger. The first multiple of 12 is definitely always going to be itself, or the first multiple of any number is itself, and then you just count by that number. So 12, 24, 36, 48, 60. Okay? Okay. So let me pull up the image. So this is going to be another one. You're going to see something like this on the test tomorrow. So we have goodie bags. Why is that important? Why is that an important word? Gabby? It's groups. And anytime we're breaking objects into identical groups, isn't that always going to be what? Ella? It's always going to be GCF. So this one, people were having some problems with it, and I think the reason why is because anytime you have larger numbers, isn't it easier to like lose numbers and forget about a 2 or something like that? So larger numbers I often see are missed sometimes. So 54 would be 6 and 9, right, everybody? And then 2 and 3. And then 3 and 3. Okay. I showed my other class this. I'd like to show you guys as well, so please listen. What if I accidentally did 2 times 2 times 3 and I forgot a 3? Is there any way to check yourself is what I guess what I'm at. Actually, it is. I did do it wrong, actually, now that I see it. It's supposed to be 2 times 3 times 3, but I still forgot a 3. So is there any way to check yourself on that? And nobody's going to do this, but I always advise people to do it. Ella? Absolutely. Take that right there and multiply it. You listen to me? You should not be writing while I'm talking. I want you guys listening. You could multiply. Like, this happens all the time where people, they'll say, I don't understand how I got it wrong. And then I say, well, where'd your 3 go? Or where'd your 2 go? Or where'd your 5 go? Okay? Multiply these out. 2 times 3 is 6. 6 times 3 is 18. Is that going to be 54? So that would be like an immediate, like, wait a minute. Oh, I missed a 3. There we go. Now for 72, that would be 8 and 9. And then 2 and 4. 2 and 2, sorry if it gets sloppy, 3 and 3, and then that's going to be 2 times 2 times 2 times 3 times 3. So you can see, what do they have in common? They have 2's in common, they have 3's in common. Anything else? More 3's. So that is how our GCF became 18. Okay. Now you may have to on the test. You may have to find the GCF, but then apply the GCF. So you might actually have to say, well, then how many bags of Skittles will go into each one? How would you figure that out? How would you figure out how many of these bags of Skittles, these mini bags of Skittles, would go into each goodie bag? Ella?
You would take skip and divide it by how much?
Opposite that, but yes. You would take the amount they have, the 72, and divide by 18. So you would know there's going to be in each one of these little bags, this is one bag, there's going to be 4 bags of Skittles, and 54 divided by 18 would be 3 M&Ms. Everybody understand that? You will have to do that step on the test. Got me?